The old vertex form of a parabola. So basically this focuses on transformations. You're going to want to write that equation down. That is the general vertex form of an equation of a parabola. We talked about standard form. This is vertex form. Another way of writing it. So this is going to really be about transformations. So think of back to Algebra 1 when we did point-slope form, right? We were able to use the point given in the equation to identify where to start our graph, and then the m part told us how steep the graph was, right? Now and then we could draw our line. So if m was greater than 1, if it was a larger number, then it would be a steeper line, and if it was, let's say, if it was a negative, then it would be a downhillsy line, right? So that's like vertex form, only with a line as the parent function instead of a parabola. So with us, we're working with quadratics, so we have a parabola as a parent function, but it's going to be same types of transformations. When you look at what the vertex is, instead of looking at where that point is, we're going to look at where the vertex is and how it's moved based on what we've written in the equation. All right, so for a quadratic, this would be the same thing, right? So instead of just a line, we have the x squared there. So now it's a quadratic equation. And instead of m, we use the value a, because the ax squared plus b plus c. So the a value there gives us how steep or vertically stretched it is. And then we use k and h instead of x and y. Now this is all to help your understanding. You don't have to actually do anything with the stuff I've told you now. So this looks almost exactly like that equation I had you write down. Now if I add k to both sides, boom, there we go. So that's why the k is positive and the h is negative. That's why you use the opposite value of that's with the x, but you use the actual value of k that's on the outside to move your vertex. So this equation is key. You got to know that. All right, and identify the vertex as the h and k. So the opposite sign of whatever is with the x, and then the actual value of the sign, k. So h and k would be our vertex. A tells you its, steepness or how vertically stretched it is. So if a is equal to 1, then it just is the over 1 up 1, over 2 up 4 pattern that we described before with parabolas. If a is larger than 1, then it's going to vertically stretch it, make it look steeper. If a is less than 1, but positive still, it's going to be vertically compressed and make it look wider or vertically squashed. And our axis of symmetry goes right through the vertex, and it's always going to be x equals this h value. So it goes right through the center, it goes through the x value of h, so x equals h is the line of symmetry. All right, sorry this is going to be a little bit longer, but let's just see a couple quick examples here. So let's graph this one. The parent function, x squared, looks like this. Now, the 2, 4, we're going to take a positive 2, so the opposite of what's with the x, and then the actual positive 4 sign, and that's going to be our vertex. So right 2, up 4 is the vertex, that's the starting point of our graph. And then, because the a value here would be 1, we're going to go 1, 1, 2, 4 in each direction, and basically just moved our parent function up and right. Another quick example. All right, so what does this do to it? We have a vertex of negative 4 for the x value, and the y value is what? Well, there's nothing written out here, so, right, opposite sign of what's on the inside there. It's like a plus 0, so it did not move up or down, so since it was not shifted up or down, we got a y value of 0 for the vertex. And then the negative in front of the equation vertically flips it, and the 3 vertically stretches it, times 3. 3 times taller. So there's the parent function. If you were to move it over and then flip it off of this point here, then it would look like that, but it's also been vertically stretched. So from the vertex, you're going to go 3 times as far for your y values. So what that does is instead of 1, 1, we have 1, 3. Instead of 2 over 2 down 4, we're going to go over 2 down 12. It's 3 times as much. So does it have a max or a min? It's got a max because it faces down. And the maximum value is 0, and that occurs at x equals -4. And our axis of symmetry is x equals -4.